You can lead a horse to water, but can't make it drink. I can lead kids to learning, but can't make them learn. I need to be able to use these academic and non-academic interventions that are going to have students learn without them having the effort of learning.
Hey, everybody, welcome to Tier 1 Interventions Podcast. We are here today to talk about a geoboard. Geoboard is a very interesting device. And when I first looked at it, I only saw it from an occupational therapy perspective where we were working on it with hand strengthening and such. But I come to see how valuable it is as a math tool as well. Today, we are going to blend the math and the occupational therapy together so that you can understand better what it looks like to have a geoboard as a intervention in your classroom. Welcome, Jonily, to today's episode and everybody else who is with us. It is great to have you here.
Chunk number three. Chunk number three is a very hot topic mathematically. I know it's a hot topic for Cheri. We have recorded content on this before, but chunk number three is going to be all about diagonals. Diagonals in mathematics are very complex, and I'm going to share mathematically how, when we go from vertical to horizontal measurements and lengths to diagonals, the math complexity increases exponentially. So I'm going to share my screen again, and I want to start with the standards. So when we have horizontal and vertical lines, we can cover kindergarten standards, counting 1 to 1, one more, how many things arranged in a line, in an array. So using dot paper and geoboards, you're covering all of your standards for counting. You're just using dot paper and geoboards as the tool. Which one is longer, shorter, positioning, greater, less than. I can add square spaces. So if I have 3 spaces here and 4 spaces here, I've got 7 altogether. Teen numbers are a 10 and some more. So on my dot paper, and I'll go ahead and show this because I'm ready for my diagonals, but I'll skip that for now. On my dot paper, I can actually do a 1 by 10. So I can make this chunk of 10, and I can have this long tens frame, put these in, whatever. But that tens frame linear, because typically we see a tens frame as a 5 on the top and a 5 on the bottom. And then we have these sections. But with scissors, if I physically cut this tens frame right here and then move this piece, and I'm going to outline it so I can move this bottom piece to the side, then I can create this long tens frame, which leads us into teen numbers, because now I have a 10 and another 4, and a 10 and a 4 is 14. So my teen numbers, huge deal in those early grades. My teen numbers can be used on dot paper and geoboards. So if you look at these kindergarten standards, more of, less of, measurement, geometry, behind, in front, above, drawing shapes. You're teaching all of your standards. You're just using the dot paper and geoboard to do that. Once I get to grade 4, things, and I'm going to, this is where things are going to move to the diagonal line, and think it's going to be important to start the diagonal line. Once I get to grade 4 in the standards, this is the first time that circles become part of the content formally. In grade 4, we start to study circles, and I'm not going to go into, Cheri, we need to make a note of this. We need to do a couple of episodes just on circles because circles are the most complex shape mathematically. Now, I know Cheri has a different perspective on circles non-mathematically, but we need to do a series of podcasts on circles. In grade 4, circles become very formal, but from the perspective of angles and degrees. So a circle is not a polygon. We don't have these straight edges. A circle, I like the definition, a collection of angles, a collection of angles. This is what really begins the diagonal line segments. And the standards don't make this connection, and we don't make this connection. So when we begin to talk about angles, which really which really is unveiled in grade 4 standards, what's not in the standards, but absolutely essential, is understanding the diagonal line. In grade 5, the coordinate plane, the XY axis, is formally introduced, as well as different types of triangles and angles on the coordinate plane. This is prepping, and this isn't written in the standards. This is what I'm telling you now, the connections. The coordinate plane and diagonal lines are prepping for 8th grade, understanding line steepness, rate, understanding the steepness, but also the length of a diagonal line and the distance from one dot to another of a diagonal line, which really is the foundation of distance formula and Pythagorean theorem, understanding the hypotenuse of right triangles. In 5th grade, the actual standards talk about triangle types, which brings in those diagonal lines. So I'm trying to make all of these standards connections that if you do just what your standards say, we are falling very short of the mathematics progressively from preschool through high school. So part of this chunk number 3, understanding diagonals, is also understanding the progression of the standards and what the standards actually mean, but it's not explicitly written. And then by the time we get to 6th grade, we're looking at coordinate plane, distance, again, prepping for Pythagorean theorem, looking at different types of polygons. And in 7th grade is the next time the circle is specifically stated in the standards. So in 7th grade, the circle comes back up, but now we're looking at circumference and area of the circle. To me, that's just area of irregular shapes. But again, a circle is a collection of angles. So we are always coming back to this diagonal line. The diagonal line, by the time we get to 8th grade in algebra, is slope and rate. And if we're not looking at steepness, which is slope and rate, then we're looking at distance and length. And of a diagonal line is where we start to uncover irrational numbers, which are in grade 8. Now, when I talked about the pizza problem in a previous episode, a pizza company makes square pizzas. I can make an exact square pizza with 25 pieces, with 16 pieces, with 36 pieces. But how do I make a square pizza with exactly 12 pieces? With unit pieces, I can't do that. But here's a different perspective. How do I create a square with area 12? I can create a square with area 12, but I'm not going to have a whole number side length of that square. That side length is going to be an irrational number. Now, I know I went pretty heavy in the mathematics there, but all of these things that I have just mentioned requires the diagonal line understanding. So if I have a line here that goes from this dot to this dot, I've got a length of 3. If I do my horizontal line, 1, 2, 3, 4, 5, I can create a length of 5. We're counting the spaces. But now I'm going to create a diagonal line from this dot through this dot to this dot. And students are going to want the length of that line to be 2. Here's the technique. Now, there are lots of techniques in studying diagonal lines. And the number one technique, because today I said shape and measurement using the Geoboard. So on the Geoboard now, I can create a diagonal line just like on my dot paper. The length of that line is not 2. And the way, now I can tell kids things. I can tell kids, don't run in the street. Don't touch the hot stove. Don't do this. Don't do that. The length of this is not 2. But the only way that kids are going to believe that is if they experience the alternative. They have to figure out for themselves at times, not by running into the busy street, but in other scenarios. And the way that we do this is we create a measuring tool with the dot paper. So I physically have kids cut out a rectangular measuring tool with the dot paper. I've already created some here. Okay, so we create this rectangular measuring tool. I'm just going to redraw that line since my tool is right here. So I have this diagonal. Kids cut out a measuring tool, and they actually can physically move the measuring tool that was created by the dot paper. So we're using the dot unit paper as the measuring tool. And if I line that up there, here's what you're going to see. The blue dots are the units, because remember, we defined a vertical or horizontal unit. So this horizontal unit is 1 unit. I just turned this. This is 2 units, and this is 3 units. But if kids actually cut this out and use the dot paper, the horizontal part, but turn it, we're going to clearly see here that green diagonal going through those dots is not a length of 2, because from here to here is a length of 2. That's how we've defined the unit. We can't change how we're defining 1 unit. So then we start to say, okay, this length is more than 2. We can use the greater than symbol. It's greater than 2. Kids can prove that to themselves. However, this length, it's a good bit greater than 2, but it's actually less than 3. So what would be a number greater than 2 or less than 3? Now, let me stop for just a minute. As we move into studying diagonal lines, we start to create salty experiences for kids. You can lead a horse to water, but can't make it drink. I can lead kids to learning, but can't make them learn. I need to be able to use these academic and non-academic interventions that are going to have students learn without them having the effort of learning. So yes, you can lead a horse to water and make it drink. How? Give it a salt lick. I can only lead kids to learning. I can't make them learn unless I find my instructional salt lick. So when I'm planning lessons and I'm planning my facilitation, I'm trying to figure out what is my salt lick. So when I say salty instruction, these are instructional facilitation techniques that make kids curious about learning. It actually does lead them to learning without them knowing it. It's salty. It's the salt lick. As I'm planning my lessons, I'm strategically thinking, what is going to make my kids thirsty so that they can't help themselves but to learn? What's going to make them thirsty is using the Geoboard tool, using the dot paper tool, using these measurement devices, and just looking at a diagonal line and them realizing, doggone it, that diagonal is greater than 2, but less than 3. Remember, I said before that measurement and shape are really the only ways that we can give experiences to improve number sense. This is where the number sense really comes in. So now I'm going to have my kids tell me, give me a number that's greater than 2 but less than 3. For a lot of kids, the only number they know is 2.5. But then they're going to look at this and say, it's bigger than 2.5. I need a number between 2.5 and 3. For many of our students, they don't even know a number between 2.5 and 3. First of all, that's a problem. Second of all, now I've enticed them to be like, there has to be a number between 2.5 and 3. So now we can start looking infinitely at numbers between numbers. So I've set myself up for more of my content standards. Let's study numbers between 2.5 and 3. Okay, so now I can have lots of prompts using this grid paper. What really comes out of this now, mathematically and non-mathematically, are the ideas of precision and accuracy. Precision and accuracy. Because you can see that there will be issues with precision when we're using these measuring tools and when kids are cutting themselves. And so we need to realize that when doing true experiments, we have to take note of precision and accuracy. Now, before I have Cheri talk a little bit about precision and accuracy from her perspective, I want to go back to this diagonal line and show a different perspective of this diagonal line. This diagonal line is actually the diagonal of a square pizza. Oops, I want the green, yes. So if I draw this diagonal again and I connect these dots, we know that the length is not 2. Kids need a lot of experience with that. But if I draw the square that is surrounding this diagonal, one of the most important things that we can teach for kids to understand rate, distance, coordinate plane, function, triangles, transformations. I haven't even talked about transformations yet, but the Geoboard and dot paper are essential for understanding transformations. So I've got this diagonal line that is the diagonal of a square. When studying the diagonals of squares and rectangles, we also have an opportunity to improve number sense, but also relating it to many of our standards as well. So the height and length of this square is 2. It's a 2 by 2. If I do the perimeter, I have 4 2's, which is 8. The perimeter is 8. The area, if I cut this up, is 4 square units. So perimeter 8 units, area 4 square units. But within this, that diagonal actually creates a triangle, and specifically a right triangle. So a right triangle, meaning I have a 90-degree angle. That's called a right angle. So you can see, remember in angles and degrees in 4th grade, we've got angles and degrees, collections of angles, parallel lines cut by a transversal in 8th grade. I'm trying to do as many standards connections as possible. So this is relevant to all of those grade levels, even though there's not a specific standard that says study the diagonal line of a square and use the reference task a square pizza to study area and perimeter, then relate that to the diagonal line. And this proves then that the diagonal of any square or rectangle is not equivalent to any of the side lengths of the square or rectangle. See, the standards don't say that either, but that is absolutely essential, an essential understanding in mathematics. But now I can talk about right triangles. This is actually an isosceles right triangle because this length and this length are the same. That's how we notate that. Now I have a hypotenuse of this right triangle. The hypotenuse of this right triangle, we know, is not a length of 2. It's somewhere between 2.5 and 3, closer to 3. Maybe it's 2.8. I don't know. We don't know. Oh, but guess what? If we're saying the length of that is 2.8, then that diagonal is greater than any of the one given sides. Now, this also leads into, when we have right triangles, the study of Pythagorean theorem. But I don't want kids to just have a formula. I don't want the first time kids see this geoboard dot paper experience, I don't want the first time for them to see this to be when we're studying Pythagorean theorem. I want kids as early as second and third grade to use this tool to study the fact that this line, this diagonal line, is not 2. I just want them to know it's not 2. By fourth and fifth grade, I want them to start to investigate that it's between 2.5 and 3. And what numbers, see, because in fourth and fifth grade, many of our standards talk about fraction and decimal. What better way to teach fraction and decimal through this dot paper experience where we're studying numbers that are between 2.5 and 3? Then, if I'm looking at a possible 2.8, now I'm really going to mess with us here for a moment. Okay. Oh, Jay-Z. Oh, Jay-Z, what are you doing to me, Jay-Z? Watch this, friends, okay? That diagonal can actually become the side length of another square, okay? So if that's the side of a square, the other sides have to be congruent, exactly the same. So I'm going to draw a square with that side length, and it's going to look like this. Okay. This is the heart and soul of Geoboard now. Is called tilted squares, which are made from diagonals. Now, remember this 2.8? Remember we said, okay, a number bigger than 2.5, smaller than 3. Let's pretend for a moment that the side length of this square is 2.8. If that's true, then I would have to, if I want to find the area of this square, then I'm going to have to calculate 2.8 times 2.8. Guess what? This is fifth and sixth grade standards, computation of decimals. So I'm going to teach my standards, but not now. My team was talking about this just this past week, how fifth grade standards look very computational, and we don't teach them in the context or concept of anything. This is how we can actually get kids to retain the content of fifth grade standards, because we just teach, okay, kids have to know decimal multiplication. Okay, yeah, who cares? But in the context of those decimals being the side length of a square, which is created visually on dot paper and a geoboard as a tilted square related to diagonal lines, and how diagonal lines are longer than any side length of the square or rectangle that the diagonal line is contained in, we start to bring about more of an experiential, conceptual, contextual learning than a procedural, algorithmic, fact-based learning. And we know that through conceptual, contextual, experiential, that kids are going to remember more, they're going to learn more, and they're going to retain that information longer than just in that procedural, algorithmic. But if I do 2.8 times 2.8, that is going to give me the area of this square. So if we find the area of that square in a different way, another way I can find the area of this square is by separating this into square units. So I'm going to connect the dots in this square. I'm going to connect the dots. And see, I actually see a square unit here. If I create my square units, the area of this blue tilted square is at least 4. So here's 1 square unit, 2, 3, 4. So the area is at least 4. Then I have this piece right here, this little triangle here that is a part of this. Okay, I've got this little triangle. All of these triangles are the same size. All of these triangles are the same size. But one of these triangles, and I'm going to get a different color here, and kids can use colors, they can use the Geoboard, they can use all sorts of stuff so that they can prove to themselves if I'm looking at these little triangles here, they are actually half of this green is actually half of this square. What's the area of this square? That's my unit square. It's a 1 by 1. This square is a 1 by 1. So the area of this square, of this whole square, is 1 unit. So these little triangle pieces are half a square. So I've got another area of 1/2. I can't draw that. I can't. Anyway, all of these little triangles have an area of 1/2, 1/2, 1/2. So my area is 1, 2, 3, 4. And how many of those little triangles? 2 halves make a whole. That's another area, 5, 6, 7, 8. So I'm telling you that this tilted blue square has an area of 8 square units. And we count up all the squares and we can have kids cut things out. We can do a lot of things to have kids discover that the area of this blue tilted square is 8 square units. So guess what, guys? If we're saying the side length is 2.8 and we do 2.8 times 2.8, we better get 8 for that computation. We're not going to, but when we do that computation, then we're going to see if that result is larger than 8 or smaller than 8. If that result is smaller than 8, then this number is too small. So instead of 2.8, I might have to use 2.9. Guess what? If I do 2.9 times 2.9 and it's too big, then I have to pick a number between 2.8 and 2.9. I could pick 2.85. Now I have to compute again. 2.85 times 2.85. The goal is I have to get a value of exactly 8. Now, spoiler alert, you are never going to find two numbers, two rational numbers that are the same that you can multiply together to get exactly 8. Now, whoa, that was hot and heavy. I had Cheri start prepping for precision and accuracy, and I went into rational numbers. But I want you to see how important the diagonal is and how the diagonal is accessible at the second and third grade level with cutting out that measurement tool from the dot paper and just saying, you know what, that diagonal line, it's bigger than 2 and less than 3. And as we move into upper elementary, it's actually bigger than 2.5 and less than 3. And then as we move into middle school and high school studying diagonal lines, I'm looking at the length and the distance and making that diagonal line the side length of a square. But that diagonal line actually has a steepness. And I haven't even talked about the steepness of that diagonal line as an up over situation. The point of this is how essential geoboards and dot paper are to teaching the majority of our standards. Oh my goodness, what is happening? Thoughts, comments, questions in chunk 3 diagonals. And then I know, Cheri, you're going to have some good bit of teaching for us as well. Thoughts, comments, and questions.
One
Cheri, I'm
thing,
not sure what you want to talk to us about, but I'm sure you have a lot to say.
Do I ever? One thing that you had said early on is don't do this, don't do that, don't do this. And I'm just going to say that don't shuts the brain down. Anything that's negative will create this compression of the subconscious brain. And it just goes, no, we're not going to whatever it is that you're going to say next because no, don't. Whatever that is going to shut down the Olympic system from accepting any teaching that you're going to share.
And
Just an FYI.
instructional facilitation technique on that note, because that's just pure psychology. In mathematics, when we negate students' wrong answers, it has the same effect. So if I say the length is not 2, okay, I can say that, but that creates that same effect. So then I want to counter that with a positive instructional facilitation technique, which is, ooh, that length is more than 2, but it's less than 3. What numbers are more than 2 and less than 3? So I want you to go back and re-listen to some of that for the subtleties of how I used the positive so that kids can connect to it rather than just the length is not 2, because that's where the barrier starts.
Beautiful. So I'm sharing my screen. And I'm just going to talk here just a little bit about writing in general. Writing is a multi-developmental step. Many times, occupational therapists talk about how our hand is being shaped for writing skills, but I want to show us what the result of just having something in your hand will do. Go away. The first thing that we are ever going to do when we're a toddler and put something in our hand, we're just going to straight across the page. Oh, it made something that is going to facilitate more of a scribble and back and forth. When we get to the point in our lives in preschool where we have a definite start point and a definite stop point, developmentally, those pre-writing strokes are naturally developed using the horizontal first. Hence, we use the X plane in our coordinate plane. The vertical is second for the y-axis in our coordinate plane. And then we can connect them together to make the coordinate plane. The circle is actually a little bit easier developmentally to create, that start point and stop point. The image that I picked did not have a good start point and stop point, but that's okay. Then we have the diagonals, the left and the right, and then we can actually incorporate combinations to create shapes. So I just wanted to say that. And then when we talk about accuracy and precision, it just happens to be on a different slide back here. And I wanted to show you that. When I was trying to comprehend how to teach teachers about motor function, there's a lot of things that we talk about. We talk about motor control, pencil control, postural control, this control, coordination, hand, eye, foot, and hand, and all these different combinations. All it is the control of the movement. So control is like that overarching mechanism that a motor movement is going to present with. If you have students that are lacking control, they're going to have trouble using those dot papers to do the geoboard. It's going to be necessary for them to have the geoboard and the bands so that they can create some control that way. Precision and accuracy aren't exactly the same thing. Accuracy is that in this picture where the A is the two diagonal lines are touching the writing lines exactly where they're supposed to be. The crossbar is touching the lines exactly where it's supposed to be. That's what accuracy is. That's the center of the bull point of the target, the middle, okay? Precision doesn't necessarily mean that it is in the bullseye. Precision could be that you got all your targets in the upper right quadrant of the target zone, it still, in this case, looks like an A, but it's not precisely or accurately on the lines the way it's supposed to be. So it's precisely an A, but it's not accurately written in the way that it's supposed to. So thinking about it from the kid's perspective with writing, they may overshoot and misinterpret that diagonal while they're trying to look at their paper and have that control, because it all comes back to the control. And then speed is really about fluency and how quickly they can get from what's in their head down on paper. So whether fluency is reading, writing, or mathematics, it's how quickly they can get it into a written form on a piece of paper. And then there's multiple varieties thereof fluency, but the basic piece of fluency is that. So I hope the idea of seeing that H, A, and A helps you a little bit when you're thinking about precision and accuracy. I had something else and it went flying out of my head. Teresa, you have any thoughts?
I find that a lot of the kids, it's the it's what they've connected with and what they feel. They don't necessarily stay within the writing line. They may go above or below, and the accuracy is not always there. They tend to and they stick with the accuracy. Whatever they've been taught, they that accuracy stays with them. Jonily, one thing that I find a lot and teachers don't get a lot of times, and I know Cheri and I both know this, whatever pencil grip they have and whatever pretty much they come in with is what they have. And so a lot of times what we try to get is legibility as opposed to changing a lot of what they've got. A lot of it is very difficult to change. So you mainly try to get legibility. See Cheri showing a pencil grip. It is really difficult to change grip unless a child is really you try adaptive grips and things like that. There are some kids you are able to facilitate with a pencil grip, but there are those who like the grips at the top and they just hold it the way they want to hold it. I have a child, it was a fourth grader. It was a fisted grip. He just he wrote completely. The teaching, as soon as a kid comes in looking like that, the teachers are like, "Oh my goodness." And I was like, as soon as I took him, he wrote and his speed and accuracy was fine. What are you gonna do? You can't change that if he's legible and the speed and accuracy are fine. You just tell them you gotta live with it. And doctors have terrible handwriting. This kid at least had legible handwriting. So you go with what you've got. The same thing. If they're able, I'm sure if they're able to get that factor, however they get it, gonna accept it. So it's the same thing with math. Some kids have math genius and you're gonna take however they manipulate the numbers. The same thing goes with the writing. However they get to that point, you're going to take whatever they give you. So I think it's all relative and you have to just, but the teachers have to understand that it's the way it is and not try to manipulate them any further.
Instead of giving kids grippers, try moving it so that their fingers are on opposite sides of the barrel of the pen, and it still gives that accuracy. It is called the Chinese grasp, and for some kids, it's just easier to control the writing utensil. Krista, were you going to ask something?
Yeah, I just typed it in the chat. I think as classroom teachers, especially I'm a gen ed teacher. So we don't have a lot of this is what you look for students who need these type of services. And so one of the obvious signs to us is, oh, that pencil grip is weird. That must be why I can't read their handwriting, or they must be struggling because of their pencil grip. And that conversation says, okay, I need to look beyond that pencil grip because that's not something that I need to worry about. It's not affecting them in the way that I think it's affecting them.
And old habits are hard to break, and some of them aren't necessary to break. Just like Teresa said, if they've got the precision, the accuracy, They've got the speed and it's working for them. How much do we try to break that habit? Maybe we just don't. However, if the handwriting is illegible, I want to bring up this point with Geoboard. Actually and physically using the rubber bands and pinching and moving and trying to do that on a Geoboard for a child is essential for improvement of fine motor.
Yep. Be careful of the bands that you use, that you don't get any latex. There are too many latex allergies out there that are emerging that we don't even know. Kid might even have an allergy to the latex. It might only be emerging. So try using silicone. There's also exercises that you can do with the hand. So if you see kids fidgeting and trying to move the band, whoops, now I can't even show it because it went flying across the room. But opening and closing, I'm going to share links to 2 YouTube videos, and they will also be in the show notes. I'm going to share links to 2 videos that I've created that help with some of the strength of your fingers that will help kids actually physically use the Geoboard.
Love it. And just to summarize chunk 3, precision and accuracy really come into play with the diagonals rather than the vertical and horizontal, because kids can physically count those vertical and horizontal. The diagonal becomes much more complex as far as length, distance, and steepness, as far as measuring. And so diagonals, we talked about all of the connections to the standards with diagonals and all of the standards that we can teach using diagonals, and I've just created a triangle there, but the diagonals using the Geoboard and dot paper, absolutely essential. And that is topic chunk solution number 3.
See you next week when we reveal chunk 4.